Polynomials. Definition. Types of polynomials. Objective. Definition of a polynomial. Types of polynomials. An engineer designing a roller coaster would use polynomials to model the curves, while a civil engineer would use polynomials to design roads, buildings, and other structures. Polynomials are also an essential tool in describing and predicting traffic patterns, so appropriate traffic control measures such as traffic lights can be implemented. Economists use polynomials to model economic growth patterns, and medical researchers use them to describe the behavior of bacterial colonies. Let's learn polynomials in detail. Polynomials. An algebraic expression of the form p of x equals to an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 plus and so on plus a1 x power 1 plus a0 x power 0, where an not equals to 0 and a0, a1, a2 and so on an are real numbers and each power of x is a positive integer is called a polynomial. Hence, an minus 1, an minus 2 are coefficients of x power n, x power n minus 1 and so on x power 0 and an x power n, an minus 1, x power n minus 1, an minus 2, x power n minus 2 and so on are terms of the polynomial. Here the term an x power n is called the leading term, and its coefficient an is the leading coefficient. For example, p of u equals to 1 by 2 u cube minus 3 u square plus 2u minus 4 is a polynomial in variable u. 1 by 2 u cube minus 3 u square, 2u minus 4 are known as terms of polynomial, and 1 by 2 minus 3, 2 minus 4 are their respective coefficients. 6x minus 2, it is not a polynomial term because the variable has a negative exponent. 1 by x square, it is not a polynomial term because the variable is in the denominator. Square root of x, it is not a polynomial term because the variable is inside a radical. 4x square, it is a polynomial term because it obeys all the rules. Types of polynomials. Generally, we divide the polynomials into 3 categories. 1. Based on number of distinct variables. 2. Based on degree. 3. Based on number of terms. Polynomials classified by number of distinct variables. One distinct variable is called univariate. Example, x plus 9. 2 distinct variable is called bivariate. Example, x plus y plus 9. 3 distinct variable is called trivariate. Example, x plus y plus z plus 9. Generally, a polynomial in more than one variable is called a multivariate polynomial. Polynomials classified by degree. The highest power of the variable in a polynomial is called the degree of a polynomial. A polynomial of degree 0 is called constant. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. A polynomial of degree 4 is called a biquadratic polynomial. A polynomial of degree n for n greater than 3 is called a polynomial of degree n, although the phrases quartic polynomial and quintic polynomial are sometimes used. The polynomial 0, which may be considered to have no terms at all, is called the zero polynomial. The degree of a non-zero constant polynomial is 0. Based on number of terms. Polynomials with only one terms are called monomials. 5x minus 6x power 4 root 2u 3 by 4y are few examples of monomials. A polynomial with two terms is called binomial. X plus 5, 2x cubed minus 3, y power 25 plus 1 are few examples of binomials. A polynomial with three terms is called a trinomial. Root 2 x cubed plus 5x plus 2, 5x squared plus 3x plus pi are few examples of trinomials. A polynomial with more than three terms is called a multinomial. X power 5 plus 4x cubed plus 4x squared minus x minus 1 is an example for multinomial. Summary.